Today I'm going to discuss how to use the spectrophotometer for our albumin lab that we will be performing this week. The things that we're going to need are the spectrophotometer, as you can see in the back, and we'll go over that in a minute. You need reagent, which comes in this box, along with standard, which came in the box, 2 levels of quality control material. You're going to need an unknown patient sample that will be provided by your instructor. You will need a 1,000 microliter pipette, a 10 and or 20 microliter pipette with tips to go with those. You will need some blank test tubes to do your mixing in, and you will need cuvettes to use for the spectrophotometer. You will need to have all of these things in front of you before you'll be able to start this lab. The first thing you will need to do is turn on your spectrophotometer. There is a light bulb in here that does need to warm up to make sure it is functioning properly. So you would turn the knob on the left to turn on your spectrophotometer. The one that I have in front of me here is a digital display spectrophotometer. There are some on some of the campuses, and we have a few on the Green Bay campus, that do have an analog display where there would be a bar that would move back and forth. That would be used the same way as the spectrophotometer. You need to take your adsorbance reading on that just like you would on here. You're just going to have to read where the lines match up. Your lab instructor will be able to help you with that. Now, what's important with this one is it shows transmittance, absorbance, concentration, and factor on here. You want to make sure that your red light is on absorbance. In order to do that with the digital display, you would push the mode button one time until the light goes next to absorbance. If we left it on transmittance, it would tell us how much light is transmitting through that cuvette, which is great, but in order to perform our calculations for our albumin lab, we do need to get the absorbance reading rather than the transmittance reading. Once you turn on your spec, let it sit for a good 10 minutes. While our spectrophotometer is warming up, we are going to go ahead and follow the manual procedure on our package insert. Your lab instructor should have handed out a sheet that looks similar to this. It may be black and white rather than have color on it because it's probably a copy. But we're going to go ahead and read through the manual procedure together and perform this. The manual procedure has a graph that lists reagent, standard, and sample. When we perform this, reagent refers to the bottle of albumin reagent, as you can see here. It talks about the standard. The standard came in the box with the reagent, and it lists albumin standard 6 grams per deciliter. This is what we're going to use to compare our patient's results to. You will also have to perform a level 2 of quality control and a level 1 of quality control that I have in my hands. Here you can see they have different colored caps. In addition to that, you will have an unknown sample. And this one here I have labeled as unknown or patient, whatever it would be that you would have on there. So we would need, for your lab today, you would need a test tube out for your standard. You need a test tube for quality control level 2, one for quality control level 1, one for your unknown, and another one for a reagent blank. So when you set up your lab today, you will have, or whenever you're doing it, you would have 5 test tubes lined up and ready to go. You would label them as reagent blank, standard, QC1, QC2, and unknown. For the time's sake of this video, I'm going to perform the standard and the unknown. You would treat your QC samples exactly like you treat your unknown. So to get started, you're going to take your test tubes here and label them. You need to label your test tubes so that you know exactly what they are. My first one here is going to be reagent blank. My second one is going to say albumin standard. And my third one will say unknown. You will have 2 more tubes that will say QC1 and QC2 as well, that you would treat the same way that you treat the patient. Now, as we read through, there's a note on the bottom that says all volumes may be increased ×2 if this instrument requires volumes greater than 1 ml. Well, we have found that these spectrophotometers from Thermo Scientific do require 2 mL to make it through the light path. So it needs to be high enough so that when that light shines through, that it can see through all the liquid in the cuvette. So we do multiply everything times at least 2 to get proper results. So looking at the graph, it says Reagent Blank needs 1 ml of reagent. Well, we are going to double everything times 2, so we are going to add 2 mL of reagent to our Reagent Blank. So you're going to put your tip on your pipette. I always pour my reagent into a separate container so that I'm not contaminating my original bottle. I like to use a nice clean cuvette. So I will be adding 2 mL, and you always want to make sure that you lightly wipe the tip to make sure you don't have any extra on the outside. I will add 2 mL of reagent to my Reagent Blank. Now reading on, it says my standard will also need 2 mL of reagent. So I will add 2 mL to my standard. Notice I am lightly wiping the edge, not wiping too much, making sure there is no air bubbles in my tip. So as you look across the manual procedure, you will see that all of our tubes will need 2 mL of reagent. 2 mL of reagent to them, need a little bit more in here. 2 mL of reagent to the unknown, 2 mL of reagent to the Reagent Blank, 2 mL of reagent to the standard. So now each of my test tubes has 2 mL in it. When you hold them up, they should all have equal levels of reagent in it. As you can see, it's green. All of our labs that we run in these spectrophotometers have different colors. Make sure you dispose of your pipette tip in the proper biohazard container. I put my tips in a biohazard hard side container because they are somewhat sharp and could poke through and could poke somebody. All right, following on with my manual procedure, I'm moving down to standard. It shows that my standard needs 10 microliters of standard. Because we're multiplying everything times 2, we will need 20 microliters of standard. So your standard is in your small vial. You will need, we only have 10 microliter pipettes on this campus, so we will do 10 microliters 2 times. Once again, you're going to grab your sample, wipe the tip very gently. If you have any extra outside of that tip, it will add an extra microliter or two to your sample. And you don't want that to happen because it could throw your results off by as much as 10% if you have 1 little microliter hanging out on your tip. You don't want to hold the tissue on there too long because it'll start to suck the standard right out of the tip. So just be really gentle and make sure there's nothing on there. I move my Reagent Blank over because we're done with him. But my standard, and make sure you look at it, you're going to put it in and give it a good mix. Now I don't want to use this dirty tip and put it back into my standard, so I grab a new tip. So put a new tip on. I'm going to grab 10 more microliters because it said we needed 20 microliters. Make sure I wipe the tip with my Chemi wipe. Grab the standard and give it a good mix. And this way I'm rinsing out the barrel of the tip. Make sure everything in there is pushed out. and put your tip in the proper biohazard container. Now when you look at our reagent blank, that's just reagent, and then you look at our standard, which you can give a good mix, you'll notice that one is a lot darker than the other. We've added albumin to our standard, so therefore not as much light is going to be able to pass through, so we're going to know there's a higher concentration of albumin in the standard tube than there is the reagent blank, which doesn't have any sample in it. Okay, so we're going to set those off to the side so we don't get confused. Next one we have is our unknown, and when we follow our manual procedure, that is known as your sample. You're going to treat your unknown, your QC level 1, and your QC level 2 just like you treat your unknown. So when you guys perform this in the lab, you're going to have an unknown, a QC1, and a QC2 that all need 20 microliters added to it. So I'm going to take my unknown, do the same thing as I did before. I'm going to grab 10 microliters of this, give it a nice little wipe. Now if you have a 20 microliter pipette, if you're fortunate enough, you would not have to change your tip and go in twice like I am. You grab a new tip, grab another 20 microliters, give it a nice wipe, go in, make sure you eject everything, and put your tip in the proper biohazard container. So once you mix, you can see that the reagent blank is just that. It's a reagent, it's light in color, doesn't have anything in it. We did our albumin standard, and we did our unknown. The unknown, I don't know if you can see very well, is a little bit lighter in color than the standard. That means most likely the standard has a higher concentration of albumin than the unknown. So when we put these in the spectrophotometer, I'm guessing that the absorbance of the albumin standard is going to be a higher number than the absorbance of the unknown, just by looking at the colors and how much light will be absorbed by the sample. Now as we read on, it says mix the contents of each cuvette. The color develops immediately. Because there's only 2 mils, we can do a really good mix by shaking them. Make sure you have your goggles on, or you can use your vortex if there is one available for you. It says here to read the standard and unknown versus the reagent blank at 550 nanometers within 15 minutes. That means we have 15 minutes to complete the lab once we have it mixed. Okay, by this time your spectrophotometer should be nice and warm. You should have been on for a good 10 or 15 minutes while you were making up all of your reagent blank, your standard, and your unknown sample along with your 2 QC samples. I'm going to show you how to do the reagent blank, and then I'm going to show you how to take the standard and the sample absorbance readings after that. Now we're on step 3 of the manual procedure. Here it says to read the standard and unknown versus the reagent blank at 300 or 550 nanometers. So we are going to change our wavelength. You can see there's a knob on top. It says wavelength right across the top. Make sure that you are in absorbance and not transmittance as well. That's something important to remember from the beginning. You want to switch your absorbance to make sure it says 550. You don't have to really crank the knob, just turn it lightly. So I am now set to 550 nanometers. The first thing we want to do is what's called blanking the spectrophotometer. What we're doing is we're telling the spectrophotometer that this sample has only reagent in it. There is no sample or albumin or standard or QC or anything added to it. It is nothing but just blank reagent. So you open your sample door, you find your you're gonna find your blank, and you want a nice clean cuvette. You want to make sure there's no fingerprints on the outside. You want to make sure there's no scratches or anything like that. You need to add your sample to your cuvette. Make sure there's no bubbles. And with the line facing forward, you want to push your cuvette all the way down into the chamber and close the door. If you don't close the door, light is going to come down into your spec. You don't want that. All you want is light shining right through your cuvette so it can be detected. If you were to have a scratch or bubbles or something in your cuvette, light would be scattered as well, so you want to make sure there's a nice clean path of light going from one side of the spectrophotometer to the other. Here, my absorbance reading says 1.22. So I'm going to write down on my lab report, I am not going to write that down. I am going to zero our spectrophotometer by turning your knob until the absorbance says 0. So you have a coarse adjustment and a fine adjustment here. I start with my coarse adjustment and turn it down till the reagent blank is set at 0. And sometimes this takes some patience. It likes to flip around pretty fast. Now if you have the analog spectrophotometer with the arm that goes back and forth, you would do the same thing until your arm is lined up at 0 absorbance. Okay, here I've got 0, 0, 0. So at 550 nanometers, the absorbance is set at 0. So the spectrophotometer knows that 100% of the light should be sent through the cuvette and 0 light should be absorbed by the cuvette. We're going to put that away. The next thing we're going to do is we're going to take the reading of our standard. So our standard, we know, has exactly 6 milligrams per deciliter of albumin in it because it said so on the vial. You want to make sure if you want to use a chemi wipe to wipe it off, there's no fingerprints on there, there's no bubbles, etc. Push that down in. Now we're going to watch to see what our absorbance is. So the absorbance of our standard equals 0.358. Okay, we're going to take that out. I like to re-zero in between my samples. We're going to put our reagent blank back in there and double check and make sure it goes down to 0. Sometimes he likes to throw himself off a little bit, so we'll re-zero in between samples here. Okay, so we're at 0. Then we're going to take our unknown. This one is our patient. You will also have a QC1 and a QC2. But for time's sake, we are going to do the unknown. So you're going to put that in, close the door, take our absorbance reading of your unknown is 0.077. And just as I thought, the absorbance of the unknown is going to be lower than the standard because when I held them up, the color of the standard was a lot darker. Make sure you remove everything. So when you're doing this in your lab, you're going to have 2 more to do. You're going to take absorbance reading of QC1 and an absorbance reading of QC2 as well. So you'll have 2 more test tubes to do. Okay, so we're going to go over how to calculate the results of your albumin. Now, as you went through in your spectrophotometer, you took a blank reading. Well, for the blank on your worksheet here, you don't have to write anything down because we simply did that to just blank the spectrophotometer and tell the spectrophotometer that, hey man, this has nothing in it, it's 0, it's just blank, okay? But then we added our standard to it and we took our absorbance reading. Our absorbance reading for our standard, as written down before, was 0.358. Okay, so you write that down. Granted, I'm writing in Sharpie because it's easier for you guys to see it. Our normal control, which you should have run, I'm going to put results in. When I ran mine, it was 0.250. My abnormal control was 0.410. Now these are fictitious numbers. You will have actual numbers from having run your normal and abnormal control, just as you did your standard. Now when we ran our unknown on the spectrophotometer, which was our patient, we got a 0.077. Okay, so you took down all of your absorbance readings while you were doing this. So you'd put your standard in, you got an absorbance of 0.358. When you put in your normal control, you got a 0.250. When you did the abnormal control, you got 0.410, and the unknown is 0.077. Do keep in mind that your numbers, when you do your lab, are not going to be the same as this. Okay, so when you're doing your lab, don't go back and look at this and panic and say, oh my gosh, my numbers are different. They may be slightly different. So what we need to do next is we have our next column, which is our albumin in grams per deciliter. When you look at the package insert underneath the manual procedure, it says results right here. Values are derived by the following equation. Serum albumin, which is in grams per deciliter, equals the absorbance of U, which is the unknown, divided by the absorbance of the standard times the concentration of the standard, which was 6. So I have that written in bigger letters up here so you can see it a little bit better. So for each answer, that's what we are going to do. Now, we know the concentration of our standard is 6.0 grams per deciliter. We know so because it says it right on the bottle. Okay, and that's what the manufacturer told us it is. The next thing we do is our normal control, which was 0.250. So according to the calculation it said to use, we take the absorbance of our unknown, which in this case is 0.250, divided by the absorbance of our standard, which is 0.358, times the concentration of our standard, which is 6. So when I plug that in, we get an albumin of 4.2 grams per deciliter. We're going to follow to our abnormal control, which is where we take the absorbance of our unknown. Your unknown is always the one that you're working with, okay? So for the next one, we take 0.410 divided by 0.358 times 6, and you plug that in your calculator, 0.410 divided by 0.358 times 6. I get a 6.9 grams per deciliter. And for our unknown, which is our patient, this is how we get the patient's results. We take the absorbance of that, which is 0.077, divided by 0.358 times 6, and we get 1.3 grams per deciliter. So this is the result of our patient right here. When we go over and look at the expected values, which is also on your package insert, we see a normal range of 3.8 to 5.1 grams per deciliter. This patient has a 1.3 grams per deciliter, which is abnormally low. You're going to have some critical thinking questions to answer on your lab for this week. And in order to answer those, you're going to need this package insert, so make sure you take that home with you after you do your lab. And it's going to ask about reagent storage and stability. It's going to ask about what do you do if your results are too